everyone, and welcome to the last session in our autumn series on F.L.O and S. If you've been with us for these sessions, you'll know that they're not a webinar, they are a meeting, so you can speak. We've had your questions in and we'll do our very best to answer them. Once we've finished, do join in with any questions at the end. Feel free to unmute yourselves and join in the discussion. So I'll introduce our presenters today. We've got Les Ryder here, who's our head of major projects, and Trevor Clements, who's our training and development principal. And they'll be answering all your questions. Still people coming in, so I'll put those people in, and I will now share my screen.
Rachel, I've pressed a button here and all of a sudden your screen doesn't appear anymore, just I see everybody else's names.
Well, my screen's about to disappear anyway when I share my screen.
Oh no, there we go.
No, I think we're all good.
Yeah.
I'm saying something's, I've just got the top end of it. What's happened there? Oh, there we go.
Okay, I hope everyone can see the slideshow there. So that's Trevor and Les. Got the same haircuts this month, so that's all good. We know who you are.
Deliberately. Keep the image up.
So we've got the first question that came in, and Trevor, do you want to read out the question and tell us the answer?
Yeah, question and answer. Yeah. So the first one off is there any room for flexibility in the U values for small new extensions, particularly walls, where the existing house is, for example, a Victorian cottage with solid brick external walls? You'll have a very highly insulated small extension and virtually no insulation to the existing house. Yeah, well, it's a reasonably quick answer to this. You're right, but there's not a lot of flexibility. The government recognises that the big problem with carbon emissions is not really new buildings, it's the existing buildings and the existing housing stock. So in the regulations, it takes any opportunity to get those upgraded. And that's why we've got the rules on renovation of thermal elements, where you're re-roofing or you're replacing a layer in a wall, and you have to consider insulation where that's economically viable. So you do have to meet the standards for a small extension. There is, I say this, there's not a lot of flexibility. There is a little bit. And Rach, if you can just blap a slide for me. You see here table 4.2 from the new Part L, approved document L. And if you look at the table, you'll see a little footnote 3 on the category for walls on the left there under element type. And then you'll see I've highlighted the footnote below in the red box. And it says that if meeting such a standard, i.e. that 0.18 U value, would reduce the internal floor area of the room bounded by the wall by more than 5%, then a lesser provision may be appropriate. So there is that tiny bit of flexibility for a very small extension. If thickening up the walls, you go over that 5%, then you could have an argument that we would listen to say, well, maybe a lesser U value would be acceptable, but it's not a huge flexibility. Rach, next slide. Just to remind people, of course, that another way of getting out of complying with Part L is if it's an exempt porch. So previous to the latest version of the approved document, porches were exempt if they were under 30 square metres, as you see here. The glazing complied with Part K, so toughened and laminated glass in critical zones. And the doors and windows that separate the extension were retained and were effectively external quality in terms of insulation. So that has now been added to. So I thought I'd bring this up at this meeting because a lot of people might have missed out. In the new Part L, we've got this clause E at the bottom, which says that to be exempt, the heating system of the dwelling must not be extended into the conservatory or porch. Now, we knew that before because that was in a government circular, but it also says that the extension must not have its own fixed heating appliance. So that wasn't there before, and that wasn't in the government circular. So you can effectively have an unheated porch. You don't have to insulate it at all if you meet those criteria. And you could have a portable heating appliance in there because it would, if it's not fixed, then it would still be exempt. So there you go. What flexibility there is, that is it. Hopefully that's a comprehensive answer.
Thanks, Trevor.
No problem.
We'll move on to the next one then. I think you're going for this one as well, aren't you?
I am, yeah, being a bit greedy up front, but so we don't want to get Les into his stride too quickly. He's still warming up. So assessments for overheating are based on the orientation of the building facade, of the building orientation of the facade with most glazing, should I say. So what happens if the orientation is midway between points on the compass? Well, it's quite an easy answer. If say the most glazed facade was at a sort of southeast orientation, then you would take the most onerous case. Whereas if it was east-southeast, as it's nearer to east, you would take east, which is less onerous than south. So if it's absolutely midway, you go for the most onerous, but otherwise you take it the nearest to the north, south, east or west. Rachel, if you could blip the slide, I think I did a slide on that just to show. Yeah, there's the table again that some of you probably seen before that says what the northeast, south and west orientations and the maximum areas of glazing that apply to those orientations. It's interesting to note that for high-risk locations, the west is the more onerous limitation for, I beg your pardon, south is the more onerous limitation for glazing, being 15 and 22, as opposed to west being 18 and 37. However, for moderate risk location, that's reversed, and west becomes the most onerous with a limit of 11 and 22 over south, which is 15 and 30. So it's interesting. I don't quite understand the science there. That's more at Leslie's door to answer that one, but just something to note that there is that switch depending on if it's high risk or not. So there you go. I hope that answers that question. Probably over answers it, as is my style. And Leslie's turn next.
Thank you, Trevor. So Les, on to
right.
number 3.
What are the basic changes to Part F in relation to simple buildings? Well, let's have a whiz through, shall we? What's the next? I think the first thing is that why is ventilation so important? I think this new approved document has homed in on the importance of ventilation, and certainly as a result of making the building more airtight and certainly more thermally efficient, then the ventilation's tending to suffer. But the bottom line is a large percentage of the UK spend most of the time indoors, and that includes virtually everybody who's watching this CPD session. We work indoors, we generally all socialise indoors. Okay, there's a few months of the year when we get outside. But the bottom line is, if the indoor air quality is poor, it's likely to affect your health. It's not like, well, the building might catch fire or the beam may, the building may fall down. The bottom line is, if you don't ventilate the property properly, then the risk of poor health increases. Nothing's ever certain in life. You either decrease the risk or you increase it, and not ventilating properly certainly increases it. Next, Rich. Next. So a few ventilation facts. People can't perceive poor air quality. Trevor's last trainee, Tom Casson, did a thesis on ventilation as part of his qualifications. And one thing that came out of that that was a surprise to me was when he did his research, the majority of people who thought that the air quality in the property was good, in fact, it wasn't. And obviously his metric was CO2. CO2 is not the most important metric, but if the CO2 in a building is high, it's generally a good indication that all of the other contaminants are high too. And so we don't have that ability to perceive poor air quality, and that's a little bit scary. And of course, there's lots of building control surveyors out there who's probably gone from property to property, do a final inspection, and they walk through the door in the winter, and they can feel that the air's stuffy. You know, the heating's turned up to 11. It's a cold day, and it's not being ventilated properly, and as a result, you know, it's a health issue. Building regulations has always controlled ventilation, certainly since '66 when the regulations first came about, and they replaced the building bylaws, which were made under the 1936 Public Health Act, and they probably controlled ventilation. It was down to the local authorities to make their own bylaws up, but I would imagine that they did, because the majority of older properties had more ventilation than the newer ones. So I would imagine it was controlled. Another interesting fact, about 70% of buildings fail the extract rate requirements when tested, and that doesn't surprise me at all. When intermittent ventilation first came into the regulations, we were very conscious about lengths of ducts and the static resistance that those ducts create, especially the flexible ones. And it doesn't surprise me, you know, if you duct in 4 or 5 meters and your extract fan is designed to go straight through the wall, then you won't get the extract rate when it's tested. It's just impossible. Always been difficult to get installers out at the same time as the test. That's what the testers tell us. Cooker hoods nearly always comply when fitted to the external walls, and that's because generally there's no ducting. It's the ducting that hurts. Utility areas are rarely sized correctly. Generally, you would imagine if that's the case, then they're putting in 15 litre per second fans instead of 30 litre per second fans, which is the standard and hasn't changed for utility rooms. And of course, the worst one is background vents are incorrectly used, if at all. And I think what people don't understand is the background vents, that's your supply air. So if you were at work and you looked up and you see the diffuser in the mechanical ventilation system, and that was switched off, you'd probably cry about it. But we do it all the time in the houses. You know, we close a lot of people close the background vents, and that is your supply air. That's what you're trying to get 10 litres per second per person. Obviously, it's very difficult. You know, it depends upon ambient conditions outside, the way that the wind's blowing, stack effect, and all the rest that goes with it. But again, a little guy testing there, most extracts fail due to incorrect sizing of the fan, poor installation, and long lengths of flexible duct. Or even long lengths of smooth duct can make a difference. But it seems odd, you know, in the 80s when they came out, it was when intermittent fans were required. We were very hot on the length of the ducts. That doesn't seem to have happened lately. Okay, next one, Rach. So the increase in thermal and air tightness of the building increases the risk of condensation and mold, high CO2 values. And high CO2 values, you know, you're not going to die as a result of high CO2 values, but it'll make you feel lethargic and it'll reduce your attention span and might make you a little bit irritable and stuff like that. But it's a great metric because it also picks everything else up, the allergens, and of course we had that tragedy where that young lad died as a result of allergens, as a result of condensation and mold. That's it's exception rather than the rule, thank God. But it highlights how dangerous some molds are. and some of them can be incredibly dangerous if they're not treated medically. And of course, odors, curries the night before, and all the rest that goes with it. You don't really want wandering around the house, so you need to ventilate to remove those aspects. And of course, all these affect the indoor air quality. So the emphasis is to build tight and ventilate right. So you heat and you ventilate. But what we tend to do, because heat is so damned expensive, we tend to put the emphasis on heating, and the ventilation tends to be forgot about, because it's the second you start ventilating right, you've got to crank the heating up. And this is where NVHR is the savior, to be fair, because now you can ventilate without cold air. You know, you can transfer the warm extract air and warm up the supply air. Next one, Rach. Oh God, my screen's right in the middle. There you go. So natural ventilation using background ventilations, intermittent extract fans are only suitable for leakier buildings where the design air permeability is either greater than 5 cubic meters an hour per square meter, or the as-built is over 3. And it makes sense, because we're relying upon that infiltration to a certain extent to ventilate the building, to help out the background vents. I've got a spreadsheet kicking around where I actually identify how much infiltration there is at different air tightnesses, and it's quite surprising. You generally get more infiltration than you do through the background vents. So like I said before, those background vents are your supply air. Cut them off, it's like putting tape over your office ventilation system, and nobody would ever do that. If the building's designed or built at higher than the above standards, you've got to use mechanical ventilation, because the background ventilation, the whole house ventilation system doesn't work. Okay, Rach, next. So a little bit on purge ventilation, that's changed. We've got windows there where we would normally accept them as 120, you know, as part of the 120th ventilation. If they only open between 15 and 30 degrees, then we've got to have at least 1/10 of the floor area of the room in ventilation. So something a little bit different there. And there's purge ventilation is purely to get rid of the contaminants in the air, to increase the, well, not specifically to increase the indoor air quality. That theoretically should be done by the background vents and the infiltration. But that's more to get rid of when the missus burns your bacon sandwich and that kind of stuff. No change in intermittent mechanical ventilation to wet rooms. That hasn't changed. Same 6 for toilets, 15 for wet rooms, 30 for utilities, 60 for kitchens, and 30 for go sewer cooker head wood. So that hasn't changed. And the next one, Rach. And this is the emphasis on the background ventilators. So now they're measured in equivalent areas, not free area. So there's basically a test. It's compared to a spherical hole. So whatever the resistance of the resistance that the background ventilator creates, that's measured against an opening that has 0 resistance. And so as a result, everything's measured in equivalent, which will be provided by the manufacturer. So you'll look for that for the manufacturer. And like I said, that's calculated in accordance with ADF1. You can have a look at how that equivalent area is calculated. So the background ventilators need the free areas marked in an accessible position, so people like myself can check them out. fitted 1750 above floor level, but that's not new. And of course, that's designed to keep to avoid drafts. Not fitted when NVHR is used, and you don't fit them in wet rooms when CAV is continuous extract ventilation is used. So if you have continuous extract in your wet rooms, you don't use background vents, because what you're trying to do, you're trying to suck that air from the habitable rooms through the wet room and out through the system there. And if you have a background ventilator in there, you'll create a short circuit. So basically, you'll just suck straight through from the background ventilator, and the way that the system's designed to work just won't work. I've had one property with CE with continuous extract ventilation, and it was brilliant. Never any condensation, and it was relatively cold in the winter, and we didn't put an awful lot of heating into the place either. But yes, it's a very, very good system. The only problem is with it, of course, it doesn't heat up your supply air. Next, Rach. Just some different background ventilation types. Classic through one at the top, as we've all seen. One I've never seen before, to be fair, this overframe design, where obviously you'll oversize or undersize the window frame, and you'll put that gadget in first, and then you'll fit the frame to the overframe background vent. So something I'd never seen, so I thought I'd stick it up there. Everybody else will be saying, well, I see loads of them. Why has he never seen them? Daft Northerner. Anyway, next. Another one I've never seen before, obviously I haven't lived, there's a background vent within the glazing. So that's another one. And of course, then there's a background vent through the open encasement, which is obviously typical of timber. Okay, next, Rach. And there's the new table 1.7. Now this has increased, so that where previously you were given certain overall background ventilation for the whole house. Now you just look at it per room rather than the whole house. So now you're looking at habitable rooms having 8,000, and kitchens having 8,000, and bathrooms having 4,000, which is odd, because I can remember years ago it was 10,000, and then it kind of dropped to 4s and 5s and things like that. But it's 8,000 now. Again, fans and background vents 500 millimeters apart. That top, the bit at the top. Because, like I said, you don't want to be creating short circuits. Minimum of 4 ventilators in a 1-bed unit, and a minimum of 5 in any other case. Obviously, you know, the more habitable rooms and kitchens and bathrooms you have, the more ventilators you're going to have. If the kitchen and the living room are combined, you're looking at 24,000 square millimeters required in 3 separate vents. Now that's how I read. I believe it's number 2, the footnote number 2. That's how I read it. To be fair, in major projects, we haven't seen anything come through new yet. It's all, everybody FLOS dodged, and we're still dealing with all the FLOS dodgers. So that's how I'm reading that at the moment, but I stand to be corrected. If anybody can correct me, it'll be Trevor. He'll be probably, I can see him, he's going through his book now. If the bathroom has no windows, I know, I've copped it a few times before. I'm talking from experience, Trev. If the bathroom has no window, then the 4,000 millimeters should be added to the ventilators in the other room. So that more or less shows how it's a little bit different to where it was before. How it was before was, it depended upon how airtight the building was, how big your background ventilators needed to be. If the building was really, it was very airtight, under 3 or 5, then the background ventilation was more to take into effect the fact that you've lost that infiltration. And of course, to be fair, that's what scares me more about ventilation than anything. I think the most people have got their health on the basis of the house on infiltration, because nobody opens windows anymore, especially in the cold months, just purely because of the price of heat. Have I got another one after this one, Rach? Can't remember. No, I haven't. That's me over. Over and out, Trev.
Over to you, Trevor. Thank you.
Excellent. And can I just chip in there? It's great to have somebody of Les's experience who can remember using the 1960 building bylaws. You know, how lucky the company is to have somebody with such a good memory of those times. Anyway, question 4. When considering the incorporation of solar shading to windows, Part O mentions overhangs with 50-degree altitude cutoff. Can you explain what that means? Yeah, I think I can, because it was something that I scratched my head on when I saw the draft Part O come in all those months ago. And I'll do that with a slide, if I may. So this is where we're looking for shading. It's one of the options that are sort of mandatory for high-risk locations. And some of you may remember that means effectively the central part of London or the London boroughs there. And if you're building in those areas, you do need to either put in external shutters, low G glazing, or overhangs, as we've just mentioned, with a 50-degree altitude cutoff. What does that mean? Next slide, please, Rach. So this is a diagram. I stumbled across this. It's absolutely perfect for discussing this point. It's showing the best possible shading strategy for a south elevation. And there you see where the 50 degrees is measured, from the bottom of the window up to the line that intersects the outer point of the shading. And by fitting the shading at that ideal position, you are getting shade from the summer sun where you've got that 50-degree altitude or above. However, you're not precluding the beneficial solar gain getting in the winter months when the sun is lower in the sky. So it is a minimum cutoff, but you could argue that it could be a maximum cutoff. It could be a maximum as well, because solar gain in the winter is a beneficial thing to have. But so that's where I am on it. That's my theory. But Les and I have had a few little debates on this, and I've got a half a mind that he might try and shoot me down this because he's got other theories. So Les, take the floor and wipe the floor with me if you wish to, and come in.
I think it's what we expected, and what I expected was that we could almost have forgot about Part O to a certain, and literally thrown it into SAP. And put it into SAP 10.2 because we already had it in SBEM, and that was, and like what we've discussed, it's measured completely different in SBEM. And if you give me the next slide, I'll explain it. Now, if you look at the diagram on the left-hand side, it takes its angle from the center of the window. And of course, obviously, as you expect with a modeling piece of software like SBEM, which is effectively, which is a modeling piece of software, you're thermally modeling the building. So that's where it came from then, and it kind of winds me up. This kind of thing. It's a bit like having, I think there should be a ministry of units and a ministry of doing things the same, because you can pick up a chord and you'll pick up one chord and pressure is in bars, and another chord it's in megapascals, and another chord and pressure in another chord is kilonewtons a square meter. This one is we measuring that angle one way through the guidance that was given from the government, and then in SBEM it's different again, and it's an old problem. I remember as an old steel designer, there was 3 different weights of snow. Domestic snow was lighter than commercial snow, and agricultural snow was lighter than domestic snow. Depend upon which building, depend upon how heavy the snow was. And it's a bit like this on here. The SBEM approach is obviously, it's a little bit more, it gives you various different angles. And the whole solar gain thing is in that really complex looking formula there. And it's not that hard really. Don't know why the sigma's there, but I'm sure a mathematician could probably tell me. But it's basically solar gain is just the radiation, the solar radiation, and that's measured. There's figures for that for different parts of the country. In megajoules a square meter. You multiply that up by your shading, which is what this fella is. You multiply that up by a factor for your blinds. You multiply that up by your G value. And you multiply that up by your glazing, and that gives you your solar gain. And then they see a load of values there. But that made me laugh. That table was, I thought that was so in a SBEM book, we've got 45 degrees latitude, which is the south of France. And then 55 degrees is North Shields, Hawaii, man. And then 65 degrees north latitude is Iceland. So, and London's kicking around, I think around about 52, so it's funny how it all, how they put all this lot together. So you'd have to interplay it between these tables. But I think what's happened is, I think it's the values will be slightly different. And so that will take into account the different measurements. But it's just another example of how things are just not consistent. And it doesn't bother people like Trevor and myself at our age. But when you've got young people coming through the system, and there's various different ways to measure the same component, it's a little bit annoying. But there you go. That's me having a moan up.
They are. Thanks for that. Yeah, I think if we put it to the vote, I think most people prefer my simple solution. But I think we can assume that's right for certainly for domestic and for overheating. But yeah, when you're delving into commercial buildings, you've got to follow the rules for SBEM. So there you are.
Thank you both. So I think Trevor, you're on number 5.
Yeah, can you talk a bit more about considerations for noise and pollution when designing to meet Part O? Yeah, I can. I'll try and keep it succinct, but it's obviously something that has to be considered. A strategy to mitigate against overheating has to be viable in terms of, preventing pollution from entering the building and also preventing the occupants being bothered by noise, both of which are going to cause some health problems. Slide, please, Rach. First thing to say is really this should all be dealt with at the planning stage. The National Planning Policy Framework, which is the basis for all planning decisions, in that hefty tome, there's the guidance you can see on the screen, and it says that account must be taken of the likely effects of pollution on health and living conditions. It also says that you should avoid new and existing development from contributing to and being put at an unacceptable risk from or being adversely affected by unacceptable levels of soil, air, water, or noise pollution. And it also says that new development can be integrated effectively, in other words, ensure new development can be integrated effectively with existing businesses and community facilities. In other words, if you're building a block of flats next to a nightclub, then you need to make provision in that block of flats to mitigate noise from the nightclub. You shouldn't then expect the nightclub to have noise abatement notices clapped on them because they're bothering the people in the flats. That's not how it's done. So all that should be tied up in planning. The relevant consultants should be consulted on. The conditions should be laid down so that when building control get the application, it should all be pretty well on the way to being resolved. Next slide, please. But if it isn't, then we do have guidance, and in Part O, it refers us to various documents, and it mentions the statistics you can see there as being a situation where if you go beyond those noise levels, then you should be looking for some sort of measures to be taken and expert advice sought. So 40 decibels averaged over 8 hours between 11 and 7, and this is obviously in bedrooms, and 55 decibels more than 10 times a night between 11 and 7. So that gives an idea of what you're trying to achieve. That's within a bedroom. Let's bear in mind the building isn't built, and I don't have the expertise to know exactly how you calculate that's a risk in the bedroom. I take it you take external noise readings and go from there. For further guidance, if anybody is interested, the Part O does mention this document you see there, or these documents, the National Model Design Code. I've had a look at that, and I can tell you it's very dilute on useful information on noise mitigation. However, the one below is certainly useful. That's the Association of Noise Consultants publication, Acoustics, Ventilation and Overheating in Residential Design Guide 2020. So if any of you got technical indexes or databases, you can probably find that's on there. Fine. Next slide. We're talking about noise, also talking about pollution. That's obviously traffic, industry, and any other sources that create a health risk. There's guidance in section 2 of approved document F for that. Obviously, it's equally relevant to ventilation as to overheating mitigation. That refers to the Indoor Air Quality Handbook for more detailed guidance. And also includes this slide, this table, 2.1, which shows the limits values for air quality standards, depending on pollutant and giving the milligram or the microgram maximums over the given exposure time. So going beyond that, then you certainly need to employ expert guidance and would need to do a proper assessment of how you're going to mitigate against that pollution. Next slide, please. There you go. There they are. So, yeah, approved document O, clause 3.5 states that buildings located near to significant local pollution sources must be designed to minimise the intake of external air pollutants. It then goes on to refer to that part of approved document F that I mentioned, section 2, and that brings in a commentary about the control of ventilation, pardon me, control of ventilation intakes and exhaust outlets, and again, detailed advice on those considerations in the Indoor Air Quality Handbook that you see there in the slide. Yeah, so hopefully that's all in planning conditions, and we can then part the loose ends before they move forward.
Yeah, Trevor, it's really, I was just, while you were talking, I was just jotting down some various bits and pieces, and it just seems now we get building control and planning are starting to join closer and closer as time's going on. You know, we're talking about you know, part B and the plan, you know, the new gateways where they're going to be part of the gateway 1 and we're going to be part of gateway 2. And then we got contamination, we joined at the hip there. We got water efficiency, so we joined at the hip there in relation to whether it's 125 or 110 litres per second per person. And we've got SUDS, where again, they're generally asking for high, you know, they're looking for a 100-year return period plus 40%, and we're looking at 30 years, well, probably 10 to be fair. Part M, designation of units. Of dwellings for designation in terms of access, whether the M41, M42, M43, and now, just as you say, now we're starting to be involved in external noise, external pollution as a result of Part O. We're going to be taking the planners over next. That's what's going to happen.
Come the glorious day, we will.
Yeah. Well, I won't.
Don't know how it's done. Sorry if there's any planners out there. It's just a witness system, I assure you.
All right. Here we. Right. So how are the developers responding to the new requirements S1 to 6? Well, at the moment, because like I think I said earlier on that we still dealing with the FLOS dodgers, There's been no large developments coming under the new schemes, just a few smaller ones. But I can't see there being a great deal of flexibility on it, and I'll tell you why. Because we will, if once we go on to the next slide, it might be able to explain. So, although there's a approved document F supports requirements S1 to 6. This is going back to the old days. This is like the 1976 regs. There are specific requirements. Therefore,
sorry, I'm too young.
Well, I was going on about specific requirements. The point, and the whole point when we sat in that room with the D of E in 1983, well, specific requirements don't give the designers sufficient, flexibility. And yet we're going back that way. We certainly gone back that way. Regulation 7, again, if we've got no authority to vary that, if anybody wants to vary it, then the only alternative is to apply for relaxation, which is what I expected on laminated glass. I thought somebody would have put a relaxation application in and would have solved that issue, instead of everybody thinking, oh, well, it just, why is laminated glass excluded and why can't we use it? Banging an application, it's refused under Reg 7, then apply for relaxation. We refuse the relaxation, then it's appealed to the government, and the government's got to make a decision. But it just never happened, and I thought it honestly would. So there's very little scope to vary the provision or provide justification or mitigation. So if compliance is not possible or it's unreasonable in a certain situation, the only route available is to apply for a building regulation relaxation under Section 8 of the Building Act. Now, I haven't seen one of them since 1982, 1983, and it was generally because the requirements didn't keep up with technology. For 5 years, we were relaxing. Now, listen to this, Trev. M49, which was for FLOs. You had to have a FLO on your gas appliance, but you couldn't have a balanced FLO. So anybody who put a balanced FLO appliance in, we had to relax it until 1984, until the approved documents came in, and the approved documents accepted balanced FLOs. But up till that point, every balanced FLO had an M49 and L13 relaxation to make it work, and that's the only system that you can use. This is probably the first requirement from start to finish which has been a specific one, which has been, which was similar to the 1976 regs, which I loved, to be fair. Much easier to work with than the approved documents. But there you go. Next, Rach, please. The one thing that there is in relation to charging for electric vehicles is shut down that. Oh, there's a cost cap, and so if the developer on assessing the situation finds out that the cost per plot effectively, or per connection, averages per connection, per plot, if that exceeds £3,600 a year, then you only put in the amount of charge points that the 3,600 will allow for. But that's only in relation to the DNO, to the district network operator, to the electricity, what used to be the electricity board. Obviously they're all different now because of privatization. So if you apply to the electricity board and said, well, I need an extra 500 or 600 amps of load for this particular development, and Southern Electric said, well, that's going to cost you £100,000, then you could, there's a possibility you could apply that cap. Now that might be an issue in West London at the moment. In West London, allegedly, they're having problems connecting to the grid because there's insufficient load available. And it's been dealt with on a first come first serve basis, but the 3,600 doesn't include the cables. It doesn't include the post or anything. It's just purely the payment to the district, to the DNO. So in the event of the connection cost exceeding, the developer must connect as many units as possible for the average sum. So it's not as if you completely get away with it. You've still got to give it a good high school try. However, in the event of a cost cap applying, cabling to the spaces would still be necessary. Remember, you weren't taking the cabling into account. You still had to pay for that. So you would still connect the cabling back to the plant room. And so that, so you're still liable for that cost. Now, one thing that is not in requirements S1 to 6 is the nominal loading of the connection of the charge point, and that's put in at 7 kilowatts. Now, I don't see a problem with 7 kilowatts because that's roughly the same as a shower. If you were connecting a piece of kit that was 7 kilowatts, you would generally use 6 millimeter squared cabling, twin and earth cabling. If you were putting a shower in, you would generally use 10, because some of these showers can go up to can go up to 10 kilowatts. So I can't see an issue with loading, and I think with the DNO fuse is 100 amps. And that's generally cut back to either 60 or 80 amps at the consumer unit. And I don't see 7 kilowatts being an issue. Now, we haven't seen any of these wired up yet. Now, normally the car park might not be a million miles away from the plant room and the plant or the meter room, because generally now everything comes in. There'll be one supply into the DNO board, that's and then from the DNO board into the meters, and so it wouldn't take much to cable from that room into the car park. And now that's basically how I personally, this is my opinion, how I see it working. So you would still have to put those cables in, but 7 kilowatts is nothing. And to be fair, if you've got a 100 kilowatt hour battery for a reasonable size electric car, it's going to take you 14 hours to charge it. The second that you're looking for a 25 kilowatt charger, if you wanted to upgrade, then you've got to go back to the network operator, because you're going to need 3-phase as well. You won't get 25 kilowatts on a single phase, so you'll end up having to put a 3-phase in. And to be fair, if you want to take advantage of off-peak electricity, which at times can only be 4 hours between 12 and 4, then you're going to need a 3-phase supply to do that. And whether you're allowed to do that in a 3-phase supply, I don't know. So lots of stuff's up in the air at the moment. Next, Rich. So S1 to 6, S1's residential buildings, only applies to associated car parking. Again, we're back to the planners. The planners will associate car parking. So if the development is not accessible, it might be 2 or 3 miles out of town, then you might have 2 car parking spaces per unit. And if you're bang in the middle of town next to the bus station and the train station, then you may have no car parking allocated. So it's only in relation to allocated car park, doesn't relate to street parking. Bottom line is a charge point should be provided to every dwelling and cabling for additional parking. So if you've got 2 car parks, 2 spaces available, or 2 spaces allocated as a result of planning, then one of them will have a charge point on, and the second space will have cabling. Houses will be connected per dwelling, as you'd expect. No real problems I don't see for houses, and especially if it's a 7 kilowatt, it'll come straight off the distribution board with a 6 or a 10 millimeter squared cable. Rules Rules apply to covered car parks where only cabling is necessary. Generally, cabling for a number of dwellings is if over 10. So it only applies if it's over 10. But the reason why there's only cabling necessary for covered car parks is because of the fire risk. I think everybody's scratching their head on this at the moment. So at the moment, there's nothing in Part S that requires charge points within covered car parks. What the philosophy is you try and get that allocated car parking outside of the building or on the surround of the building, and then you put your posts there, you put your charging points there, so it keeps the fire risk to the outside of the building. That's the theory. KRH next. S2 is change of use. So if any one of the following is being carried out, and it's basically these definitions is all within the requirements: substantial work the car parks, resurfacing, installation. I'm not going to read all of them fellas out because it's, you know, if you're in that situation, you've got to pick the requirement up and read it. But again, we're into this situation where you would, if it's a change of use, you're looking at the existing load capacity of the building. And if the load capacity of the building will only allow for perhaps 3 7-kilowatt posts to be provided, then that's all you need to provide. But you still need to provide cabling as if there were capacity, even if it's a covered car park. And obviously that's going to be, as like I said, it seems to be the jury's out on it at the moment. And as we all aware, you know, the fire brigade and charge points in multi-story car parks is a bit of an issue at the moment. But again, if you think that the capacity of the building isn't sufficient, then you've got to provide evidence for it. And that wouldn't be a difficult calculation. Very difficult one to fudge, but a very easy one to prove if that's the actual case. So what you're trying to do is to prove that that the full installation is not possible without an upgrade. Okay, next one, Rach. Again, residential buildings undergoing major renovation. Major renovations is defined if it's more than 25% of the facades being upgraded, and again applies to buildings with more than 10 allocated car parking spaces after renovation. And again, the philosophy is still the same. Every dwelling must have access to a charge point, and cabling to be provided for the remaining. But it only applies to the capacity of the existing supply. Cabling to be provided as if there was capacity, even if it's a covered car park. And again, the evidence situation applies again. But this is just a brief overrun, as it's quite a complex document, as you can probably imagine. Make sure that whatever situation you're in, you look and check it all out for yourselves. Next one, Rach. Non-residential or non-mixed use. Again, the 10 allocated car parking spaces. The building must have access to one charging point, and then one in every 5 of the remaining spaces to be serviced with cabling. And it only applies to car parks within the building or the boundary. So if you've got 20 car parking spaces, then you get your 10 allocated with 1 post, and then you would cable for another 2. So that's the theory. That's the theory there. Okay, Rach, next one. S5 non-residential applies to build, again, the 10 allocated spaces. Building must have access to 1 charging point, and again, exactly the same. Only applies if the capacity, if it has the capacity, if it's an upgrade. Cabling to be provided as if there was capacity, even if it's a covered car park. And again, the evidence situation's important. On the last one, Rach. I think it's the last one. And the S6 is the mixed use building. It seems to be really complex in the approved document, but the theory is quite simple, is that the residential part has got to comply with S1, 2, 3. So a charge point per dwelling, and cabling for anything that's remaining. And the commercial part would comply with S4, S5. So 1 charge point for the building, and then 1 in 5 spaces to be serviced with cabling. It's pretty dry session, that, to be fair, but it kind of gives you an idea what's going down. I think that's the last one, Rach, isn't it?
Yes,
Yeah, it is.
Thank you.
TC.
Last one, Trevor. I think this is the.
Yeah, no, it's interesting with that last one, Les. It's a lot of food for thought, as you say, a lot up in the air still, which I've been to see how the dust settles on that. Right, finally, last question. Is anything in the pipeline to replace the very useful LABC guide to meeting new value targets on domestic extensions? This is out of date since the changes to Part L in June of this year. Well, I'd like to kiss on both cheeks the person who raised that question, because it does segue very well into trumpeting the announcement of a new document that we're working on. Rach, if you could give us the next slide. Just to give people a background, because a lot of people will know about this document. It was brought out by Hertfordshire in 2006, in fact, the Hertfordshire Technical Forum, and has evolved since then and has been adopted as an LABC national guidance note. There you see it, and that is the sort of table on the right that you get in there, which will give you a menu of solutions to meet the maximum U value targets in the regulations at the time, which was 2006. So obviously that's now gone by the board because we've got new targets. And so just to let you know, we are working with manufacturers on a new guide for 2023, and we hope very early in 2023 to make that available to you. Rach, if you have a slide, please. You are the first to see this. This is a very advanced review of the sort of information it's going to contain. That's just one manufacturer's menu, Saint Gobain, who produce Celotex and also fibre products. And you'll see there's a table for masonry cavity walls, which is the one we're all particularly interested in, and full fill cavity walls. And it just gives all the different solutions. So you can look at that and you can select what sort of block you're going to use. You'll see that the lambda values of the blocks are on the right. So whether you're going to use from one extreme the Thermalite Turbo, the ultra lightweights, aircrete blocks, or whether you're going to use an aggregate block or even a more dense block, you will find solutions to meet that. And obviously, with the less efficient blocks, then the cavities get thickened up and the insulation gets thickened up. But there you go. That's just a taster. We've also got other companies involved, Rockwall, Actis, and others. And we're going to put all those together in one guide, and we'll certainly, anybody who's on our mailing list, Rachel will make you aware when that's available and send a link to you. So thanks for that question. I did want to trumpet about that, which I've now done.
Thanks, Trevor. We have had one question in the chat from Andy to say number 3.5 note says that Part F is a controlled fitting, but the rainbow regs do not concur with that. Do you know about that?
I'm in trouble now because I would look at the rainbow regs.
Yeah, I mean, I think it is a controlled fitting is a fitting that is covered under, I think, Part F and Part J. I'll have to see if I can drum it up actually. So I think something like a mechanical ventilator and something like that would be a control fitting. But let's see if I can find the regulation. We haven't really got time, have we? Control fitting means a service or fitting in relation to which parts G, H, J, L, or P. They're absolutely right, aren't they? Not Part F imposes a requirement. So that is a good question then, isn't it? it wouldn't be defined in the rainbow regs as a control fitting. So what was the full question? Oh yeah, 3 months.
IRA 3.5 note says that Part F is a control fitting, but the rainbow regs do not concur.
Right. Well, they've got Andy, you've flummoxed me, because you're absolutely right. There's a anomaly there that we need to.
Yeah, I know, Trev. Is it okay if I speak then?
Yeah, please do.
Yeah.
So it's a first note under 3.5, and it clearly says ventilation equipment is considered to be a controlled service or fitting, but it's not in the rainbow regs. So what is the answer? I don't know.
The answer is
the crazy thing about it, Andy, that's the only way. That's the legislation that allows us to control existing windows, isn't it? So it's but that without that.
Yeah, just a discrepancy. That's all. Just
yeah, sure.
I'm sure we'll get an answer one day.
Yeah, great spot though. Great spot.
The regs would trump the approved document, I guess. The regs are legislation. The approved document is a way of complying. So, but it's I think the LABC technical group, and I know a few people on that. We'll get them to take that back to the government and ask them for a clarification on that, and hopefully we'll see it in their FAQ section on their website very soon. But it started with you, Andy. So thanks for chipping in.
Thank you. That's it. And Neil's giving us some kind of image to download. I haven't done it yet. Do you want to enlighten us if Neil's still on? Do you want to tell us about the image? Not hearing from Neil. No, I will
download it. See what it is.
My leisure then. I can always pass it on in the post event email.
Yeah, sorry, I just cut and paste the section from the manual which refers to Part L. So it might come, you might be able to get it under the Part L part.
Oh, that's in the manual, right. Okay.
So if you download that extraction, it's just from the manual which refers to Part L, and that could be mechanical extraction or something relating to Windows.
Yeah, although it's Part F was the case in point, wasn't it, that we were looking at?
Yeah, we had a similar question when someone didn't want to put trickle vents in, but they were talking about putting a mechanical ventilation system in to stop the trickle vents. And we said that we could potentially control the mechanical ventilation under the Part L, but not the trickle vents part of it. So we deemed it under Schedule 1. But I'm not sure if other people would do the same.
Yeah, interesting. Well, yeah, there's more than one way to skin a cat, and it's interesting to hear that's how you did it. So thanks for the contribution.
Before we close, does anybody have any more questions? Anything on what we've covered today in particular? Before I bring things to a close.
I've got one question. In terms of the Part S, when doing a plan check, what should the architect or agent provide? Is there any specific details for new build, new dwelling? You're on mute, Les.
Yeah, definitely defer to Les on Part S.
Yeah.
On that.
I think you certainly need a car parking plan or something along those lines, because sooner or later those spaces will be allocated. So I don't think it's unreasonable to ask for a plan to be provided and to identify the kit. But that's that obviously we on new ground, but certainly I think that if I was on the other side of the fence and I was trying to demonstrate it, I think that would be the easiest way to do it. To demonstrate it would be to provide because they need a plan for planning. So you just literally have to superimpose over that with the necessary information that you would need to gain compliance with Part S.
Okay, thank you.
Anything else? What would you say to that, Trev? Does that seem reasonable?
It sounds perfectly reasonable. Well, the reason I did that is because I just see Mark Harvey's face pop up on screen, and I owe him a bottle of champagne. So when you're next in the UK, Mark, I'll put my hand in my pocket, I promise.
Yeah, well, he's good at asking awkward questions as well.
Yeah, we'll keep him muted, Rachel. Yeah, no, I agree with that, Les. I think, yeah, we don't need too much information, just layouts and kit, and just so it's evident what the allocated spaces are, and that the cabling will be run to them, and which ones will receive charge points, so that they can be checked on completion, that they are in place and operable. So there you are.
Hi, can anybody hear me?
Yes.
My name is, can you hear me? My name is Teresa Walters.
Yeah, we can hear you.
I have a query about both Part F and certainly Part S. The Part F query, or the Part L query, I should say, it's concerning the extension, which is highly insulated to current standards. Okay, and you've got and where your extension abuts a historic wall, masonry wall, it's not that clear about the risks, I think, in promoting sort of thermal bridging, because of a highly insulated part of fabric. And then you've got this historic fabric, which is not insulated. You could have cold bridging. And I wondered whether you could, we used to have flexibility under the old Part L to have a look at historic fabric, and to either they extend the insulation to a certain amount, or else they reduce slightly with to give us calculations on fabric efficiency and condensation risk. Is that feasible? Is that what everybody's doing, or?
Les, chip in, please.
Yeah, I think it's what we used to do years ago, and it seems to have gone out of fashion a little bit. If it was let's assume it was old school cavity rather than solid. I think we've got a problem with solid, but with cavities, we used to cut the cavities out. And then apply the starters or the bonding on the outside leaf, and then put a starter on the inside leaf. In which case the insulation would run through that particular point, and it would help. It would certainly reduce the U value to 0.35, which is the problem with the limiting value, the limiting factor, which is a condensation issue, and that's how we'd use. But it seems to have gone out of fashion. When I came down south, nobody did that. They just put 2 starter bars on and off they went, and they might stick a still saw down to put a vertical damp course in. So my philosophy is, and when I had the architectural company, I would always specify that cavity be cut out with a still saw. And then that alleviates that particular situation. But if it's 9-inch brickwork, then it's more of a problem.
Yes, I agree. And the other, thank you for that. Okay, so the jury's out on that one. I think it's going to be on a case-by-case basis, certainly on my sites. But the other,
there's definitely still sorry to interrupt, but just a point, there's definitely still flexibility in the new Part L. You don't have to unacceptably alter the listed building. You get the best out of it, and sometimes that might mean a cold bridge. You can't start cutting into historic fabric of building just to take out a cold bridge, and we still have that flexibility. And we, certainly in Hertfordshire, we would be open to discussing that and just getting the best out of it.
Because of the possibility, there's a lot of attention now to mold and damp, and I don't think enough is, I think we probably need more guidance on trying to avoid that with new extensions, and where it abuts historic fabric. But thank you for that. The other query I had was Part S. Now, I think that I would advise that Part S6 is very, very, to me as a building control surveyor, it is Very interesting to read that part of part S6, because when we come to the actual charging points and everything, it actually refers to supporting documents, and it refers to all other things like part M, part B, fire safety, how close it should be to sprinklers, provision, etc. The where it is located in relation to means of escape routes, all sorts of things, circulation around the cars themselves. And I think that is well worth reading. However, planning might have a look at the allocated car parking, associated car parking spaces, but from our point of view, looking at the cabling and and those charging point locations is quite useful. I think, part S6, I particularly personally found that one is most informative for me. One of the most informative.
You're certainly 100% right to say, because the majority of medium and high rise that we see are mixed use. So this issue is going to come to the fore very, very quickly. So yes, but you're 100% right. And that's why I said, I certainly didn't have time to cover S6 other than just the basic principles of it. But yes, you're 100% right. That's why I said, the planning drawings which allocate the car parking, because obviously it's a material planning consideration. The details there, they've just got to stick a layer on top of it so we can check it for all of the aspects that you were talking about.
Absolutely, and thank you for that. And I thought the part S was very, very useful guidance as well. That thank you for that. Okay, thank you.
Thanks for your contribution.
Thank you. I think we're nearly at 5:15 now. So we'll bring that to a close. Your CPD certificates will come around tomorrow. They're downloadable, so that you'll see sort of Gutenberg certificates, and you just need to download your personal certificate there. And then I'll be in touch in the new year. So Merry Christmas from us, and hope to see you all in the new year. Thank you.
Cheers all. Have a great break, and maybe see you in 2023 if we haven't put you off on this presentation.
Happy Christmas.
Happy Christmas. Thank you. Cheers.
Thank you very much. Thank you.
Bye for now. Bye bye. Thank you.
A pleasure, everybody.